Several solutions can be considered to address the issue of metal halide lights tripping the circuit when turned on and off quickly. Firstly, consider a time delay relay. Installing a time delay relay in the circuit prevents the lights from being turned back on too quickly after they have been turned off. This gives the transformers sufficient time to reset, which is crucial for metal halide lamps. Metal halide lamps require a cool-down period before they can be reignited. When power is interrupted and then immediately restored, the hot lamp presents a low impedance, drawing a large inrush current that can trip the circuit breaker. A time delay relay ensures that a minimum off time is enforced, allowing the lamp to cool down and the arc to extinguish fully. Secondly, explore the use of a surge protector with a built-in time delay feature. This device prevents power surges from tripping the circuit and also delays the re-energization of the lights. Metal halide lamps are prone to causing voltage surges when they are switched on, contributing to the risk of tripping the circuit breaker. The surge protector absorbs these surges, while the time delay feature prevents immediate re-energization, giving the transformers time to reset. Thirdly, think about replacing the standard three-way switch with a smart switch that allows for timed control. Smart switches offer programmable delays and can be set to turn the lights on or off at specific times or after a specified delay. This method offers precise control over the lighting system, preventing unauthorized or accidental rapid cycling of the lights. The smart switch can be programmed with a minimum off time, ensuring that the metal halide lamps have sufficient time to cool down before being reignited. Fourthly, consider transformer isolation. Installing an isolation transformer between the circuit and the lights isolates the transformers from the circuit, preventing circuit tripping. An isolation transformer provides electrical isolation, which helps in reducing the impact of inrush currents and voltage surges on the main circuit. By isolating the metal halide lamp transformers, the risk of tripping the circuit breaker is significantly reduced. Fifthly, consider a remote access control system. Installing a remote access control system allows for remote control of the lights, preventing unauthorized access to the switches near the door. Remote access can be controlled via a secure interface, such as a smartphone app or a web-based platform, giving the ability to turn the lights on or off from a distance. This method prevents kids from rapidly cycling the lights, which could lead to circuit tripping. Sixthly, keyed outlet covers may be a solution. Using a keyed outlet cover prevents access to the switches. This requires a key to operate the switches, preventing accidental or unauthorized turning off. Keyed outlet covers provide a physical barrier, preventing unauthorized users from operating the switches. This simple solution can effectively prevent unintentional or malicious rapid cycling of the lights. Seventhly, physical modifications can be made to limit access to the switches, such as installing a barrier or placing the switches in a difficult-to-reach location. This approach can involve installing a physical barrier around the switches, making it more difficult for unauthorized individuals to access them. Alternatively, the switches can be relocated to a less accessible location, such as behind a locked panel or in a higher position. Additional considerations should be taken into account when implementing these solutions. Ensure that the wiring is properly sized for the load and that the circuit breaker is the correct size. Undersized wiring can overheat, leading to voltage drops and potential fire hazards. The circuit breaker should be sized according to the total load of the metal halide lamps and any other devices connected to the circuit. NEC Table 310.15 provides guidance on proper conductor sizing based on ampacity and temperature ratings. Also, check the transformers to make sure they are not defective. Defective transformers can draw excessive current or produce voltage surges, leading to circuit tripping. Use a multimeter to measure the input and output voltages of the transformers. Ensure that they are operating within the specified voltage ranges. Test the solutions thoroughly before putting the lights back into regular use. Use an ammeter to measure the inrush current when the lights are turned on. Ensure that the inrush current does not exceed the rating of the circuit breaker. Monitor the circuit voltage to ensure that it remains stable when the lights are operating. Lastly, consider installing a sign warning users not to turn the lights off and on rapidly. A clear and concise warning sign can help prevent unintentional rapid cycling of the lights. The sign should be placed near the switches and should be easily visible to all users. It should clearly state that rapid cycling of the lights can cause the circuit breaker to trip. Metal halide lamps, while efficient light sources, present unique challenges due to their operating characteristics. They require a starting voltage to initiate the arc, and once ignited, they generate a significant amount of heat. If power is interrupted, the lamp must cool down before it can be reignited. Attempting to reignite a hot metal halide lamp results in a large inrush current, which can trip the circuit breaker. The inrush current is typically several times higher than the normal operating current of the lamp. For example, a 70-watt metal halide lamp operating at 120 volts typically draws around 0.6 amps under normal conditions. However, the inrush current can be as high as 5 or 6 amps. This inrush current can overload the circuit breaker, causing it to trip. The cool-down period for metal halide lamps varies depending on the lamp type and the ambient temperature. However, it is generally recommended to wait at least 5 to 10 minutes before attempting to reignite the lamp. A time delay relay is an electromechanical or solid-state device that introduces a time delay into a circuit. It can be used to prevent the lights from being turned back on too quickly after they have been turned off. There are two main types of time delay relays. Firstly, on-delay relays which activate after a specified time period has elapsed after the input signal is applied. Secondly, off-delay relays which maintain their state when the input signal is removed, and then deactivate after a specified time period. For this application, an off-delay relay would be more appropriate. When the lights are turned off, the relay would maintain the circuit open for a specified time period, preventing the lights from being turned back on until the cool-down period has elapsed. The time delay should be set to at least 5 to 10 minutes. A surge protector is a device that protects electrical equipment from voltage spikes and surges. It typically contains metal oxide varistors (MOVs) that divert excess voltage to ground. Surge protectors with a built-in time delay feature can prevent power surges from tripping the circuit and can also delay the re-energization of the lights. The time delay feature works similarly to a time delay relay, preventing the lights from being turned back on too quickly. Smart switches offer advanced control and monitoring capabilities. They can be controlled remotely via a smartphone app or a web-based platform. They can also be programmed with timers and schedules. SWAT switches with timed control can be used to turn the lights on or off at specific times or after a specified delay. This provides precise control over the lighting system and prevents unauthorized or accidental rapid cycling of the lights. Smart switches can also provide valuable data on energy consumption and operating hours. An isolation transformer is a transformer with separate primary and secondary windings. It provides electrical isolation between the input and output circuits. Isolation transformers can be used to isolate the metal halide lamp transformers from the main circuit, preventing circuit tripping. They also help to reduce noise and interference on the electrical system. The isolation transformer should be sized appropriately for the total load of the metal halide lamps. A remote access control system allows authorized users to control the lights remotely. This can be achieved using a variety of technologies, such as radio frequency remote controls, infrared remote controls, or internet-based control systems. Remote access control systems can be used to prevent unauthorized access to the switches near the door and prevent kids from rapidly cycling the lights. Heat outlet covers provide a simple and effective way to prevent unauthorized access to the switches. They consist of a standard outlet cover with a built-in lock. A key is required to open the cover and access the switches. Heat outlet covers are relatively inexpensive and easy to install. Limiting switch access through physical modifications involves installing a barrier or placing the switches in a difficult-to-reach location. This approach can be customized to suit the specific layout of the clubhouse. The barrier can be constructed from a variety of materials such as wood, metal, or plastic. The switches can be relocated to a high position on the wall or behind a lock panel. Ensuring proper wiring size is crucial for the safe and reliable operation of the lighting system. The wiring should be sized according to the total load of the metal halide lamps and any other devices connected to the circuit. Undersized wiring can overheat, leading to voltage drops and potential fire hazards. NEC Table 310.15 provides guidance on proper conductor sizing based on ampacity and temperature ratings. The circuit breaker should be sized appropriately for the total load of the metal halide lamps and any other devices connected to the circuit. An undersized circuit breaker will trip frequently, while an oversized circuit breaker will not provide adequate protection against overloads and short circuits. The circuit breaker should be rated to interrupt the maximum fault current that could occur in the circuit. Defective transformers can cause a variety of problems, including excessive current draw, voltage surges, and circuit tripping. Use a multimeter to measure the input and output voltages of the transformers. Ensure that they are operating within the specified voltage ranges. Also, check the transformers for signs of damage, such as cracks, leaks, or discoloration. Testing the solutions thoroughly is essential to ensure that they are effective and safe. Use an ammeter to measure the inrush current when the lights are turned on. Ensure that the inrush current does not exceed the rating of the circuit breaker. Monitor the circuit voltage to ensure that it remains stable when the lights are operating. Also, check the transformers for signs of overheating. Installing a sign warning users not to turn the lights off and on rapidly can help prevent unintentional rapid cycling of the lights. The sign should be placed near the switches and should be easily visible to all users. It should clearly state that rapid cycling of the lights can cause the circuit breaker to trip. The sign should also include instructions on how to properly operate the lights. In conclusion, there are several possible solutions to address the issue of metal halide lights tripping the circuit when turned on and off quickly. These solutions include time delay relays, surge protectors, smart switches, transformer isolation, remote access control systems, keyed outlet covers, and physical modifications to limit switch access. Additional considerations include ensuring proper wiring size, sizing the circuit breaker correctly, checking the transformers for defects, testing the solutions thoroughly, and installing a sign warning users not to turn the lights off and on rapidly. By implementing these solutions and following these recommendations, one can effectively prevent circuit tripping and ensure the safe and reliable operation of the metal halide lighting system.